Some of you expressed difficulty with the solving linear inequalities, which is section 2.7, embedded within lesson 4. So I'm going to work through the homework problems from the textbook, which is on page 149. You were assigned questions 7 through 13 odd and number 29 and 31. So we'll begin with number 7, which is 3x plus 2 greater than or equal to 7x minus 1. So initially, when you look at this, it is an inequality, but to solve it, you basically use the same techniques that you would use to solve an equation. So I need to get all of the x's together on one side and all of the numbers together on the other side. Really, with inequalities, it is better if you will put your variables or your letters on the left and your numbers on the right. And then, of course, you'd have the inequality symbol within the problem. It doesn't have to be that way, but it makes it easier for interpretation purposes a little bit later on. So that would be my encouragement. So I'm going to move the 7x from the right side to the left side by subtracting 7x from either side, which gives me negative 4x plus 2 is greater than or equal to negative 1. I'm then going to subtract 2 to get all of the numbers together on the right-hand side. So I have negative 4x is greater than or equal to negative 3. Then I need to divide both sides by negative 4 so that I have x, and then I have 3/4 is my numeric value. Now here's where you got to be really careful. There is a rule about inequalities, and when you multiply or divide by a negative number, as we did here, you have to invert or flip the inequality. So ultimately my answer in equation form is x is less than or equal to 3/4 or 3/4. So then if I look at that on a number line, which may help you out, okay, so think about it, you have 0, and then if you want to think about it, you'd have 1, but 3/4 is going to kind of be partially between that 0 and 1, and it's equal to it, so I'm going to use a colored in dot. That's my 3/4. And then I want to be less than that. Less than is going to be numbers to the left. So visually on a number line, that's what it would look like. If I write it in interval notation, again, remember for interval notation, we work left to right. So I'll be going from negative infinity up to positive 3/4. Negative infinity always gets a parenthesis. 3/4 is going to get a bracket because it is equal and can be used in the problem. Number 9, again, treat it like it's an equation initially. So the first thing I want to do is to distribute and get rid of the parentheses. So I'm going to do 4 times x is 4x. 4 times positive 3 is 12, which is greater than or equal to 2x minus 1. I then want to try to get all of my variables on the left. So I'm going to subtract 2x from either side. So I have 2x plus 12 is greater than or equal to negative 1. I then need to get all of my numbers together. So I'm going to subtract 12 from either side. So I have 2x is greater than or equal to negative 13. I'm then going to divide both sides by 2. Okay, and I'm going to take it up here to the side because I'm running out of space. And so I end up with x is greater than or equal to negative 13 over 2. Now this time, you might think, well, Ms. Ross, you divided by negative. No, I didn't. I actually divided by a positive 2. So since it was a positive 2, I do not invert my symbol. So we think about this in terms of a number line. Negative 13 halves be somewhere here on the left. I can use the negative 13 halves because it's equal, so we would have a colored in dot, and I want to be greater than, so I want numbers to the right. And again, that has that idea of the connotation, it goes to positive infinity. So we would begin at negative 13 halves, go to positive infinity. Infinity always gets a parenthesis. We can use the negative 13 halves, so we would use a bracket. Number 11, again, if you're going to treat it like an equation to start with, on the left, I want to distribute. So I have negative 5 times x is negative 5x. Negative 5 times minus 1 is plus 5. Plus 3 is greater than. And on the right-hand side, I'm going to combine like terms. 3x minus 4x is minus 1x minus 4. And then I am going to come back and on the left side combine like terms as well. So first of all, I have simplified my equation so that I basically have all the letters combined together on the left and all the numbers combined together on the left, and the same thing on the right. I combined all the letters together and I combined all the numbers together so that I don't have multiple pieces. I've simplified it from having 3 pieces to 2 pieces, or from 3 pieces to 2 pieces, however you want to view it. Okay, so then I need to get all of the variables together on the left. So I'm going to add x. So I have negative 4x plus 8 is greater than negative 4. I'm then going to subtract 8 from either side. So I have negative 4x is greater than negative 12. I'm going to divide by negative 4 on either side. Be careful, because notice we are dividing by a negative 4, which means I'm going to have x is less than, you need to invert your symbol, positive 3. Negative divided by negative is a positive. Looking at that on a number line then, you'd have your 0 in the middle. Here's 3. The 3, its x is less than 3, so 3 is not usable, so we'd have an open circle, and less than goes to the left. So that would give me from negative infinity on the left up to 3, not including it, so we use a parenthesis. So the interval would be negative infinity to 3. Okay, 13's a little bit trickier because you have the fractions. And so the first thing I would tell you to do is to eliminate the fractions by multiplying through by the common denominator. So I need a number that 8, 5, and 10 will all divide into evenly. So my least common denominator here is going to be 40. So I'm going to multiply each piece of the problem by 40, and I'm going to write it out for you. So I would have 40 times x plus 3 over 8 minus 40 times x plus 5 over 5 greater than or equal to 40 times 3/10. And then I'm going to simplify each of those. 8 divides into 40 5 times. So I have 5 times x plus 3 minus 5 divides into 40 8 times. So I have 8 times x plus 5 is greater than or equal to 10 goes into 40 4 times. So I would have 4 times 3. Now I've written it all out. Some of you may be able to do some of that in your head, and that's fine. Then I'm going to come back and I'm going to distribute, get rid of the parentheses, and combine like terms. So I would have 5 times x is 5x. 5 times positive 3 is positive 15. Now be careful because I'm going to do negative 8. Negative 8 times x is negative 8x. Negative 8 times positive 5 is negative 40, and that's greater than or equal to 4 times 3 is 12. Okay, then I need to combine like terms on the left side. So we have 5x minus 3x, or excuse me, 5x minus 8x, which is negative 3x, plus 15 minus 40 is minus 25, is greater than or equal to 12. Again, we're trying to solve ultimately for x. Oops, my negative sign went away on the 3. Sorry. Okay. So then the next step I'm going to do is add 25 to either side to get the numbers all together on the right side. I have negative 3x greater than or equal to 37. I'm then going to divide both sides by negative 3. And again, be careful. We are dividing by a negative number, so I need to invert the inequality so it becomes less than or equal to. And I have positive 37 over negative 3, so it's really negative 37 thirds. So if we think about this in terms of a number line, okay, it is equal to it, so we could include negative 37 thirds. So we would have a colored in or a shaded in dot. Less than is going to be to the left, and it keeps going on and on and on to negative infinity. So writing that in interval notation, beginning at the left, I would have a negative infinity, and I can go up to negative 37 thirds. Negative infinity always gets a parenthesis. We can use negative 37 thirds, so it is a bracket. Question 29, it looks a little tricky because you have 3 pieces, but you have 3x plus 1 greater than 2x minus 5 greater than x minus 7. In this particular case, what you want to do in terms of solving it is you want to have a number, the variable in the middle, and then another number. So we want to try to get all the variables into the middle, and then you'll have some numbers on the front end and the back end. So I'm going to subtract 3x. I'm going to do them one step at a time. So I have 1 is greater than negative x minus 5, which is greater than x minus 7. Okay. So then I'm going to, if I move the other x, and I think we're going to have a little error here, we're going to subtract x to get the x from the back end moved over. So we have 1 is greater than negative 2x minus 5 is greater than negative 7. Then I need to get the x isolated. So I need to add 5 to the beginning of the problem as well as the end of the problem. Because remember, what you do to one, you got to do to the other, or in this case, to all the pieces. So we're going to have 6 is greater than negative 2x, which is greater than negative 2. All right, so then we need to come back and we've got to divide by negative 2 all the way across. Okay, now be careful because here we're dividing by negative 2, so we are going to invert. So 6 divided by negative 2 is negative 3. Flip the inequality. Negative 2 divided by negative 2 is going to be 1x. Flip the inequality. Negative 2 divided by negative 2 is 1. So we end up with an answer that says we can have any value between negative 3 and positive 1. So visually, if you look at this one on a number line, we can use a value of beginning at negative 3. So we could use negative 2.8, negative 2.6, negative 2.5, negative 2, negative 1. So all the way up to positive 1, but the endpoints are not included because it's not equal. So I don't include the endpoints. We would have open circles in terms of our number line. So in interval notation, we're saying we can go from negative 3 to positive 1, not including either endpoint. So you would have a parenthesis on the negative 3 as well as a parenthesis on the positive 1. One more. And this is an or statement. You have two separate inequalities. But it's saying it could be, you could have just the first one or just the second one. And so we need to solve both of them. You have to solve both problems separately. So for 2x minus 5 less than negative 11, I'm going to add 5 to either side to isolate the x on the left. I'd have 2x is less than negative 6. I'm then going to divide both sides by positive 2. So I'm dividing by a positive 2. So x is less than negative 3. Going back and doing the second problem, 5x plus 1 is greater than or equal to 6. I would have negative, subtract 1 from either side. So I have 5x is greater than or equal to positive 5. Then divide both sides by positive 5. So x is greater than or equal to 1. Now when you graph this, you graph both solutions on the same number line because of the or. Okay, so if I graph x is less than negative 3, okay, the negative 3 is not included, so we have an open dot. Less than is to the left, which implies it goes on to negative infinity. Then we have x is greater than or equal to positive 1. The 1 could be included because it's greater than or equal to, so the dot is colored in, and greater than is to the right, which seems, again, implies it goes on forever and ever. So here you have two separate pieces. Mathematically, the symbol for the word or is this U shape. It's called the union. And in mathematics, that's the symbol for or. So we would have from negative infinity to 3, not including it, so we use a parenthesis, or that little horseshoe looking symbol. Then we would have beginning at positive 1 to positive infinity. Infinity always gets a parenthesis. We actually can use or include the 1 so it gets a bracket.